Hey there, universe nerds. Have you ever wondered what the universe looks like on the largest possible scale? Not just galaxies or clusters, but everything all at once. If we could step back far enough, past stars, past galaxies, past superclusters, we'd see something extraordinary. A vast interconnected network that looks like a web of light stretching across billions of light years. It's called the cosmic web, and it's the universe's hidden structure, the grand design behind everything we see. The story of the cosmic web begins shortly after the Big Bang, when the universe was still a hot, nearly uniform sea of matter and energy. But nearly is the key word. Tiny density fluctuations, just 1 part in 100,000, left imprints in the cosmic microwave background. Over billions of years, gravity amplified those tiny irregularities. Regions slightly denser than their surroundings pulled in more matter, growing denser still, while emptier regions emptied further. This cosmic feedback eventually created a pattern, a structure, woven from dark matter and ordinary matter alike. That pattern became the web. So, what exactly is the cosmic web made of? Picture an enormous three-dimensional network of filaments, nodes, and voids. The filaments are vast tendrils of galaxies and dark matter, each hundreds of millions of light years long, connecting massive clusters called nodes. Between them lie gigantic empty regions, the cosmic voids, where there's almost nothing at all. If the universe were a body, the cosmic web would be its skeleton. If it were a brain, the web would be its neural network. Everything, from our Milky Way to the farthest galaxy we've ever seen, sits somewhere along this cosmic structure. Scientists first began to suspect this hidden architecture in the 1980s, when deep galaxy surveys like the CFA Redshift survey mapped large regions of space for the first time. Instead of finding galaxies evenly scattered, astronomers discovered that they formed patterns, long walls, thin threads, and huge empty bubbles. One of the first major structures identified was the Great Wall, a filament of galaxies stretching over 500 million light years. Later surveys like Sloan Digital Sky Survey, SDSS, revealed even larger ones, like the Sloan Great Wall and the Boss Great Wall, massive cosmic filaments that make our galaxy seem impossibly small. But the real backbone of the cosmic web isn't ordinary matter, it's dark matter. Invisible and mysterious, dark matter makes up about 85% of the total mass in the universe. It doesn't emit light, but it shapes space with its gravity, guiding where galaxies form. Think of dark matter as the scaffolding of the universe. Ordinary matter, gas, dust, stars, simply collects along its gravitational blueprint. We see galaxies along the filaments not because they're randomly placed, but because dark matter told them where to go. Without dark matter, there would be no web, just chaos. Today, computer simulations like the Millennium Simulation and Illustris TNG have recreated the cosmic web in astonishing detail. They show that the structure of the universe looks strikingly like biological systems, filaments connecting nodes like neurons in a brain. On both cosmic and microscopic scales, the geometry of complexity seems to repeat itself. Scientists have even compared the mathematical structure of the cosmic web to that of neural networks, suggesting that the universe might be self-organizing in ways we're only beginning to understand. But the web isn't static, it's alive with motion. Galaxies stream along its filaments, flowing toward massive nodes like rivers converging at the ocean. Over billions of years, these filaments feed galaxy clusters, sustaining star formation and galactic growth. Meanwhile, the cosmic voids expand, pushing filaments further apart. The universe isn't just expanding, it's stretching its web. And because of dark energy, that process is accelerating. Eventually, distant filaments will drift beyond our observable horizon, leaving only our local cosmic neighborhood visible. One of the most astonishing things about the cosmic web is how much of it we can't see. Only a small fraction of it matter emits light. Most of it is either dark matter or warm, hot intergalactic medium, WIM, diffuse gas that glows faintly in X-rays and ultraviolet light. Scientists have spent decades hunting for this missing matter, and only recently have telescopes like Chandra and XMM Newton begun to detect it along the filaments. Bit by bit, the invisible web is revealing itself. The cosmic web also helps us understand where we fit in. Our Milky Way sits inside a filament of the Laniakea supercluster, flowing along the currents of dark matter toward the great attractor we talked about last episode. Every motion we make, from our solar system's drift to our galaxy's orbit, is part of this grander gravitational choreography. We're not just floating in space, we're moving along the threads of the universe's vast design. So what is the cosmic web? It's the universe's architecture, a colossal network woven from gravity, matter, and time. It's the map of everything that exists, from the smallest galaxies to the greatest clusters. And it's a reminder that the universe isn't random chaos, but a masterpiece of interconnected structure, elegant, vast, and still expanding. When you look at the night sky, you're seeing just one glowing thread in a cosmic web that stretches forever, connecting everything, including us.